In this video, we're going to take a look at an example of finding the limit at infinity. In this case, the limit as x goes to infinity of minus 3x to the fourth plus 3x squared plus 1, which is a polynomial function. Okay, so this is our first example of finding a limit like this. We can't treat this like we can the limit as x goes to a number and just plug the number in, because there aren't really any rules for doing arithmetic on infinity or minus infinity. So what we're going to do is to try and reduce this down to a polynomial or a power function form. And how we're going to do that is we're going to do that by factoring out the highest power of x that we see. So here we have x to the fourth, x squared, and no x here. So what we're going to do is we are going to factor out an x to the fourth. And now you may say, well, how are you supposed to do that? Because these terms don't have x to the fourths in there. Well, turns out that you can do that. You can factor out what you like, as long as you divide by what you're factoring out. So here I want to factor out an x to the fourth, so I'm going to pull that out in front. And then what I would do is go through and divide every term by what I factored out there. So negative 3x to the fourth, divide that by x to the fourth. 3x squared, divide that by x to the fourth. And 1, divide that by x to the fourth. So you can see if I decided to multiply this back out, which you don't want to do, but if I did, I'd have to distribute that x to the fourth through each of these terms, and it would cancel out each time, and I would wind up with exactly what I started with here. So these two things are equivalent to one another. Okay? All right. So next up, what I want to do is reduce some of these terms in here. So x to the fourth divided by x to the fourth will just be, or negative 3x to the fourth divided by x to the fourth will be negative 3. Here I had 3x squared and x to the fourth in the bottom. So these two of these x's here will cancel with 2 in the bottom and leave me with that. And 1x to the fourth, there's not much I can do with that. Okay, next up, I'm just going to do a little simplifying here and look at here I'd have 3 times 1 over x squared. That's the same as 3 over x squared. And so I just did that just to see that, we have a power function right here, 1 over x squared. And here we have 1 over x to the fourth. So now we've got everything simplified as much as we can. We're just going to look at each of these individual pieces and see what happens to them as x goes to infinity. So if you remember, x to the fourth was a power function, right? And as x goes to infinity, this goes to positive infinity here. Negative 3 is just a constant, right? And as x goes to infinity, then it just remains as negative 3 here. So nothing different here. With 1 over x squared, right? Remember, that was one of those power functions, 1 over x to some number power, and all of those went to 0 as x went to infinity or minus infinity. So 1 over x squared will go to 0. Also 1 over x to the fourth will go to 0 as x goes to infinity. So here we are really relying on those rules about the power functions, what their limits were as x went to infinity. So to summarize that up, here's what we said here. This limit is infinity. Negative 3 is just negative 3. The 1 over x squared will go to 0. And the 1 over x to the fourth will also go to 0. So just simplifying that out a little bit. Basically, the x to the fourth goes to infinity, and the expression in parentheses will go to negative 3. So what's happening here is that x to the fourth is getting really, really large, right? It's as x goes to infinity, it's getting really, really big. So it'll be a really big positive number, and then I am multiplying that by a negative number. So really what I have here is a positive number times a negative number, right? And in absolute value, it will be really, really big. So the conclusion here is that the limit as x goes to infinity of the original function is going to be negative infinity right here. Okay, infinity part comes from here, the fact that in absolute value these things, numbers are getting huge, the output's getting huge, but here, because of that negative, right, it's not going to go to positive infinity, it's going to go to negative infinity. That negative 3 is going to make those numbers change sign. So